Alright, let's look at the hallmark 2.5, problem number 4. Alright, let's find this derivative. Alright, so when we want to take the derivative, actually I don't like square root there, so I'm going to rewrite it as you have a 4x over x plus 3, and write it as a 1/2 power. Right? Alright, so let's take the derivative. Alright, so this is going to be, 1/2, a general power rule. Alright, then keep the inside function as it is. Alright, subtract 1 from the power, so it's going to be negative 1/2. Alright, multiply by derivative inside. Alright, so we need to take the derivative inside, we have to use the quotient rule. Alright, square the bottom, so you're going to get x plus 3 squared. Alright, and actually I'm going to leave the 4 outside here, right? Because that 4, and I'm going to just put it here, right? Then derivative of the top, which is going to be just x, is going to be 1 times the bottom, which is x plus 3, minus, top is x, times derivative of the bottom is going to be 1. Alright, and that way we can actually cancel, there's x there, minus x to cancel out, so you just get only 3 left over there. Alright, so this is going to be equal to, we just need to clean it up a little bit. So here, alright, so we have, let's see, 4, actually, we should go ahead and cancel those. Alright, there's a 4 on top, and there's a 2 on the bottom, so at least this becomes 2 on top. So we have a 2 on top. Alright, so I'm just going to put, let's see, 2 on top. Alright, so that takes care of this guy. Alright, then we also have, actually, we have a 3 on top too, so I have to make that 6. Alright, so I'm going to erase that. Oops. Use the eraser to erase that. And that's going to be 6. Alright. Then here, this is going to be, let's see, it's going to be negative, which means that it's going to be a reciprocal. So I'm going to go ahead and write a reciprocal there. So you have x plus 3 over 4x, right? Then you have a square root, so there's a square root there, right? Right, then multiply by, right, so 1 over, right, because this 3 is already incorporated here, then you have x plus 3 squared. Alright, so that doesn't look very nice, so I'm going to try my best to make it look a little bit cleaner. So this is going to be equal to, alright, so here's 6 there, so I'm going to put 6 up here, right? Then here, and we're going to have, let's see, square root, let's see, square root of 4x. So you have on the bottom, you have a square root of 4x, but the square root of 4 is 2, so I'm going to write it as 2 square root of x, right? Then on top here, right, so we can actually do a little bit of cancellation. So x plus 3, then there's a square root. So x plus 3 to the 1/2 power. So you have, there's a 2 power here. So you're going to have x plus 3, right? So 1/2 cancel out. So 2 minus 1/2 would be 3 halves, right? So I guess if you want, we can actually even write it this way. So 6 and 2 cancel out. So that's going to be 3. And then there's a square root involved, so I can probably write it as a 3 over. Then I can put everyone under the square root. Then you have an x times. You have x plus 3 cubed. Alright, so let's type it in. right? It's going to be 3 over square root of x times x plus 3 cubed, right? So let's check the answer. Submit for testing. All right, it came back and looks like we got the derivative correctly. All right, so we want to, next part is we want to sketch the graph of the original function and its derivative. All right, so let's pull out the graphing calculator. All right, so there's a calculator here, so I'm going to type in, I have to get rid of the previous junk here. All right, so I'm going to write the square root, so I'm going to have a square root there. And then we have a 4x divided by quantity x plus 3. Right, so that's the original function. And the derivative function, I'm going to put it as y2. So I'm going to do a 3 divided by, then we put the square root, and then we have x times, and the quantity x plus 3 raise it to the third power, right? And hit enter there, right? So let's look at the picture. So I'm going to hit graph. All right, it's drawing the picture there. All right. All right, so it looks like the color is kind of backward, but you can see that actually the first one looks pretty good, and the second one does not look very close at all. And the third one is definitely different, and the fourth one is different. So you can see that the first one is the correct picture, right? So let's type it. Let's submit for testing. All right, I came back. Looks like we got this one correctly. All right, so let's look at the next one. All right, describe the behavior of the function when the derivative is 0. All right, tangent line of f is horizontal where f prime is 0. So this is actually right. All right, let's look at the other ones. F has a local maximum where f prime is equal to 0. All right, so would that be true? So I'm going to look at the picture. All right, so derivative is the 0. Let's see, which one's the derivative? Let's see, I'm going to just open up the graphing calculator, right? So here, derivative is the red one, right? So here's the red one, right? And when the derivative is 0, but you can see that if you look at the formula, derivative is actually never 0. All right, so let's see, is there any other choice? I chose this one, maybe I should unclick that one. Let's see, tangent line is vertical, no. Oh, here, this is the right answer. F prime is never 0 in this case, because here, if you look at the formula here, right, and numerator is 3, so no matter what x value you plug in, the derivative is never 0. Right, so answer is f prime is never 0. Right, so let's check the answer. Submit for testing. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.